Methods to solve T equations. The first method is use of factorization. So in this, factorization gives us smaller equations which can then be solved easily. For example, uh, if we have some a into b plus b into c, we can take b common from here and we can equate it with 0. So from here we can equate b equal to 0 or a plus c equal to 0. So we'll get smaller equations from a larger one. Next, equations in quadratic form, right? The quadratic equations can be factorized using the splitting the middle term method. This we have already studied in the quadratic chapter, like in your 10th, 9th, right? So from there, you can split the middle term and just find the roots. Like it's like that. By assuming cos x is equal to some variable t or sin x is equal to some variable t, like that. So let's see a few examples in this. In this question, we need to find the general solution of this equation. So here, let's see how can we do this. This cos square x can be written in the terms of sin square x, right, by using the basic identity. Why should we change like that? Why can't we change sin in terms of cos? Because from here, we can change easily, and also you will get these kind of ideas upon practicing, right? As many questions you practice, you will get that many ideas like where to change, what to change, and how, and a lot. So just multiply it, you'll get 2 minus 2 sine square x plus 3 sine x is equal to 0. Now this can be written as 2 sine square x minus 3 sine x minus 2 is equal to 0. If you use factorization, this can be written as just split this middle term. So it becomes 2 sine square x minus 4 sine x plus sine x minus 2. I hope you all know how to factorize, right? Take 2 sine x common from here. Inside it will left over with sine x minus 2. Similarly, 1 take common, sine x minus 2. Now from these two, take sine x minus 2 common. And inside it's 2 sine x plus 1 is equal to 0. Now, there's a chance that this value can be 0 or this value can be 0. So we can write it as sin x equal to 2 or sin x can be minus 1 by 2. Is it possible that sin x can be 2? No, right? We know the sin x lies in the range 0 to 1. So how can it be 2? So just ignore this case. So in this case, we can write it as sin x as minus sine pi by 6. This can be written as sine 7 pi by 6. If you know the basics, you can just write it directly. Now this is in the form of sine theta is equal to sine alpha. Then the general solution will be x is equal to n pi plus minus 1 whole power n 7 pi by 6, where n belongs to all the integers. So this is the final general solution for this equation. In this question, we need to find the general solution for this equation. Here, one thing to remember is we should know the formula of sine 2x. What's the formula for sine 2x? Which is nothing but 2 sin x into cos x. So now this can be written as 2. Just replace the formula over here, that is 2 sin x cos x, and it is whole square. Don't forget about that. And minus 6 cos square x plus 1 is 0. It becomes 2, 2 square, 4 2s are 8, sin square x, cos square x, minus 6 cos square x plus 1 is 0. Again, write this sine square in terms of cos. It becomes 8 into 1 minus cos square x into cos square x minus 6 cos square x plus 1 is 0. Now, here we need to assume let cos square x will be t. Now we can write it as 8 into 1 minus t into t minus 6t plus 1. Now it will be easier for your calculation. It becomes 8t minus 8t square minus 6t plus 1 is 0, and 8t minus 60 is 2t. 8t square minus 2t minus 1 is 0. Now split the middle term, like the general, it is in the quadratic equation, right? So it can be written as 8t square minus 4t plus 2t minus 1 is 0. Take 4t common, it becomes 2t minus 1. So 2t minus 1 will get 2t minus 1 into 4t plus 1 is 0. Again, we'll get two cases over here. In the case 1, which is 2t minus 1 is 0, or 4t plus 1 is 0. T is nothing but 1 by 2. So t is nothing but what? Cos square x, right? So cos x becomes under root 1 by 2. Or it becomes cos square x is half. So this 1 by 2 we need to write in terms of cos square some value. So if you observe, we can write it as 1 by root 2 whole square, right? So we can write cos square x is equal to cos square pi by 4. Isn't it correct? Now it's in the form of cos square theta is equal to cos square alpha. For this, what is the general solution? It is x is equal to n pi plus or minus alpha. Alpha is nothing but pi by 4, where n belongs to all the integers. Similarly, if you look here, t becomes minus 1 by 4. And here t is nothing but what? Cos square x. If you do something square, if you square a number, the output will be positive. But here, if you carefully observe, when you are squaring this cos square x, you are getting negative value. So reject this, ignore this case. So the general solution is this for the given equation. In this question, we need to find the general solution of this equation. So again, we can write this as 2 sin x minus cos x into 1 plus cos x minus sine square x is 0. Write sine square in terms of cos. Why? Because if you think the next step of that, after taking, after writing sine in terms of cos, you can take something common. So for that, we need to convert sine to cos. So it becomes minus 1 minus cos square x. Now, this is the same thing. This can be written as a square minus b square, right? So 1 plus cos x into 1 minus cos x. Now here also 1 plus cos x is there. So take common. it will be 2 sin x minus cos x. And this minus gets multiplied here. It becomes minus 1 plus cos x equal to 0. Here this and this gets cancelled. Now 1 plus cos x into 2 sin x minus 1 equal to 0. Now we have two cases. Case 1 is 1 plus cos x is 0, and other cases 2 sin x minus 1 is 0. From here we can write it as cos x is equal to minus 1 and sin x is equal to half. Is in the terms of cos theta equal to minus 1. For this we have seen a general solution for simple t equation. So this can be written as x is equal to 2n plus 1 times of pi, where n belongs to all the integers. Similarly, now this is in the format of sin theta is equal to sin alpha. From here we can write x is equal to 2, n pi plus minus 1 whole power n alpha is nothing but pi by 6, where again n belongs to all the integers. So here both these two solutions are correct. So for this equation, these are the two general solutions. Find the general solution for this equation. If you observe here, on the RHS and LHS, what is common? Tan theta is common, something related to tan. So here we need to convert this sine 2 theta in terms of tan. So there's a formula, right? Sine 2 theta can be written as 2 tan theta by 1 plus tan square theta. So use this formula, substitute over there, and also for the easier calculation, assume tan theta is some t variable. So we can write it as 1 plus tan theta is nothing but t and 1 minus sine 2 theta. Here from here it becomes 2t by 1 plus t square. So just write as it is and bring this 1 minus tan theta on this side. It becomes 1 minus t is 0. So just do LCM over here, that is 1 plus t, 1 plus t square minus 2t by 1 plus t square 1 minus t. So this is in the form of a minus b whole square. So it becomes 1 minus t whole square upon 1 plus t square 1 minus t. This, if you take 1 minus t common from both of these, what the leftover part will be? 1 plus t into 1 minus t, because 1 minus t, 1 we have taken out, but 1 is still inside, upon 1 plus t square, and this becomes 1 equal to 0. Now this is in the form of a plus b into a minus b. So it becomes 1 minus t square by 1 plus t square minus 1 is 0. So if you remember, formula for cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. So it's nothing but 1 minus t square by 1 plus t square according to our assumption. So this can be written as 1 minus t, and this is nothing but cos 2 theta minus 1 is 0. And From here, we'll get two cases, that is 1 minus tan theta can be 0 or cos theta minus 1 is 0. So here tan theta is equal to 1, which is nothing but tan pi by 4. So now this equation is in the form of tan theta is equal to tan alpha. So the general solution of theta will be n pi plus alpha. Alpha is nothing but pi by 4, where n belongs to all the integers. And here cos 2 theta is 1. Now it becomes cos 0. So again, this is in the form of cos theta equal to cos alpha. Then the general solution will be theta here, it's 2 theta, right? So it becomes 2 theta is equal to 2n pi plus or minus alpha, but alpha is 0, so just leave that. We'll get theta as n pi, where n belongs to all the integers. So these are the two general equations for the given equation. The next method to solve the equation is using of quadratic formula. So the quadratic equations can be solved using the quadratic formula. What is the quadratic formula? If x is a variable and we need to find the solutions of x or the values of x, then quadratic formula can be written as x is equal to minus b plus or minus under root b square minus 4ac by 2a. And here the quadratic equation used is ax square plus bx plus c. So the values of x can be found out using this quadratic formula. So in few equations, it might be easier if you apply the splitting method. But in few equations, if you won't get any splitting method or like in few equations, if there is nothing to split, then you can use this quadratic formula. So let's see few examples. So here is an example in which we need to solve this equation. Solve in the sense we need to find the general solution of this. So let's do this. First convert this sign in terms of cos. So we can write 2 cos square x plus 4 cos x minus 3 sine square x is nothing but 1 minus cos square x is equal to 0. So it becomes 2 cos square x plus 4 cos x minus 3 plus 3 cos square x. So it becomes 5 cos square x plus 4 cos x minus 3. If you see, this kind of equations cannot be solved using the splitting method, splitting the middle term method. So here we can use the quadratic formula. So we can write x as, here if you observe with the quadratic equation, the value of a will be 5, b will be 4 and c will be minus 3. So just substitute in the formula, you will get it as minus b, minus 4 plus or minus under root b square. So 16 minus 4ac. So 5 was at 20, 23, 60, but c is negative. So it becomes plus 60 under root 2a, that is 10. Here it should be actually cos x, because cos x whole thing is a variable over here. If we convert into quadratic form. So this can be written as, so it is written as cos x is equal to minus 4 plus or minus under root 76. 76 can be written as 4 into 19, right? So if you take 4 common outside, like out of the root, it becomes 2 under root 19 upon 10. So take 2 common, it becomes minus 2 plus or minus under root 19 upon 5. So again, two possible cases. Case 1 is cos x will be minus 2 minus under root 19 upon 5. If you calculate this value, it is less than minus 1. But we know that cos x belongs to minus 1 to 1. So this value is rejected. So other cases, cos x will be minus 2 plus under root 19 by 5. This can be written as under root 19 minus 2 by 5. If we assume this whole thing as cos alpha, assume this thing as cos alpha, then the solution can be written as x is equal to 2n pi plus or minus alpha, and here n belongs to all the integers, but alpha is nothing but cos inverse of under root 19 minus 2 by 5 from here, right? So this is the required general solution for the given equation. In this question, we need to find the general solution for this equation. We know our identity that is related to secant and tan, right? We can write secant square x as 1 minus tan square x. Sorry, 1 plus tan square x. Now, using this identity, we can write here secant square 2x will be 1 plus tan square 2x, and on RHS it is same 1 minus tan 2x. 1 and 1 gets cancelled. Now, this can be written as tan square 2x plus tan 2x is equal to 0. So take tan 2x common. The remaining thing is tan 2x plus 1 is 0. We get two cases in which one is tan 2x is 0, which is nothing but tan 2x is tan 0. If you compare this with tan theta is equal to tan alpha, then the solution will be 2x is nothing but n pi plus alpha. Alpha is nothing but 0. So from here you can write x as n pi by 2, where n belongs to all the integers. And what about the second case? It is tan 2x is equal to minus 1. We can write this as tan 2x is equal to tan 3 pi by 4. Why 3 pi by 4? Minus 1. This can be written as minus tan pi by 4. So if you observe the four coordinates, tan is positive over here, negative, positive, and negative. So this is negative. So this can be written as pi minus pi by 4, because here it's negative. If you write in the terms of pi minus pi by 4, it's nothing but tan 3 pi by 4. Now this is in the form of tan theta. This is in the form of tan theta equal to tan alpha. So the general solution will be 2x is equal to n pi plus alpha. Alpha is nothing but 3 pi by 4. And x is nothing but n pi by 2 plus 3 pi by 8, where n belongs to all the integers. So these are the two general solutions for the given equation. In this question, we need to solve this equation. That is, we need to find the general solution for this equation. So, if you know the basic conversion of sine to cos, that is, sine theta can be written as cos of pi by 2 minus theta. So, use the same thing over here and you can write it as cos 2x. Sine theta can be converted as cos of pi by 2 minus 3x. Or else you can also convert cos to sine, and this RHS side remains the same. So this is in the form of cos theta is equal to cos alpha. So we can write 2x is equal to 2n pi plus or minus alpha, which is nothing but pi by 2 minus 3x. So again, two cases possible. That is 2x is equal to 2n pi. If you take plus, one case, or if you take minus, it is other case. It becomes 2n pi minus pi by 2 minus of minus plus 3x it becomes. Now we can write this as plus 5x is equal to 2n pi plus pi by 2. From here we'll get x as 2n pi by 5 plus pi by 10, where n belongs to all the integers. Similarly, solve here. You'll get minus x is equal to 2n pi minus pi by 2. So x is nothing but minus 2n pi, that is pi by 2 minus 2n pi, and n belongs to all the integers. So these are the two general solutions for the given equation. In this question, we need to find the general solution of 16 sine square x plus 16 cos square x is equal to 10. So first, convert either sine in terms of cos or cos in terms of sine. So here I'm just converting cos in terms of sine. So it will be 16 whole power 1 minus sine square x is equal to 10. Now this can be written as 16 sine square x power, okay? 16 whole power a minus b. It can be written as 16 by 16 power sine square x is equal to 10. Now assume let 16 power sine square x some variable t. Now this can be written as t plus 16 by t is equal to 10, and convert into quadratic equation, it becomes t square minus 10t plus 16 equal to 0. And from here we can write t minus 2, t minus 8 is equal to 0. From here we'll get two cases. Case 1 is t equal to 2 and case 2 is t is equal to 8. Now what is t? It's nothing but 16 sine square x is equal to 2. As we have base 2 on the RHS side, so convert LHS in such a way that 2 should be at the base. 16 we can written as 2 power 4 into sine square x as a 2 power 1. Now bases are equal, just equate the powers. We will get it as 4 sine square x is equal to, it becomes sine square x is equal to 1 by 4, which can be written as 1 by 2 whole square, which is nothing but sine square pi by 6. For this, we can write the general solution. It's in the form of sine square theta equal to sine square alpha. So it's nothing but x is equal to n pi plus or minus alpha. Alpha is nothing but pi by 6, where n belongs to all the integers. So similarly, it is 16 whole power sine square x is equal to 8. So here convert both LHS and RHS so that their bases should be equal. So we can write this as again 2 power 4 and write 8 also in such a way that base should be 2. It becomes 2 cube. From here, directly we can write it as sine square x is equal to 3 by 4, which is nothing but root 3 by 2 whole square. So sine square pi by 3. Again, it's in the form of sine square theta is equal to sine square alpha. Therefore, x is equal to n pi plus or minus alpha. Alpha is nothing but pi by 3. Again, n belongs to all the integers. Hence, these are the two general solutions for the given equation.